Okay, 7.1, we're talking about moles. And so the reason we use a mole to express a number of particles is because that number is so big. So chemists use the measurement called a mole to represent 6.02 times 10 to the 23rd atoms of a substance. So that's 6.02, and then move your decimal place 23 places to the right. So it's a huge number. That's called Avogadro's number. And so it's a lot easier to say 1 mole rather than 6.02 times 10 to the 23rd atoms. And that is why we use that number. It just makes measurement easier. So think of it like any other word that you use for a number. So a dozen is 12. A ream of paper is 500 sheets. 100 is 100. So think of it as that same type of measurement. Okay? So a dozen is 12, 100 is 100, and a mole is 6.02 times 10 to the 23rd, number of things. So when we talk about molar mass, we're talking about the mass of 1 mole of a substance. So carbon, for example, if I had 6.02 times 10 to the 23rd atoms of carbon, the mass would be 12.011 grams, or we can round that to 12 grams. Now that happens to be the same number as the atomic mass of that element. So if you look on your periodic table and you look in that bottom number at the atomic mass, that is expressed in atomic mass units, which if you remember back, that's 1/12 of a carbon-12 atom. But that number tells you the number of grams in a mole of that substance. Now if you look here on this page, a mole of carbon weighs 12 grams. A mole of sulfur weighs 32.1 grams. That's because sulfur is a bigger atom. It weighs more, just like a bowling ball weighs more than a tennis ball. It's bigger. So sulfur weighs more than carbon because it's bigger. It has more protons and neutrons. Therefore, it has more mass. Okay? So if I had 100 bowling balls and 100 tennis balls, I would have the same number of each. But the mass of 100 bowling balls is a lot more than the mass of 100 tennis balls. Same way, if I had a mole of carbon atoms and I had a mole of sulfur atoms, the mole of sulfur atoms would weigh a lot more because it's a bigger atom. So to calculate the molar mass of a compound, we simply just add up the molar masses of all the component parts. So for example, carbon dioxide has a molar mass of 44 grams. Well, how did they come up with that number? Well, a carbon atom, which there is one of in carbon dioxide, weighs 12 grams. A mole of carbon weighs 12 grams. A mole of oxygen weighs 16 grams. And there are 2 of those in carbon dioxide. So 16 and 16 is 32, and 12 is 44. So a mole of carbon dioxide, or 6.02 times 10 to the 23rd molecules of carbon dioxide, weighs 44 grams. Now, once we know the molar mass of an element or the molar mass of a compound, we can flip back and forth between number of moles and number of grams. Okay? And we can do that using a conversion factor. So if you notice on this page, there's 2 ways to show that, 2 ways to express that relationship. I could write 44 grams of carbon dioxide over 1 mole of carbon dioxide. That means 44 grams per mole of carbon dioxide, or I could write it 1 mole of carbon dioxide over 44 grams of carbon dioxide, meaning 1 mole per 44 grams of carbon dioxide. So suppose I have 55 grams of carbon dioxide. I put it on a balance and I measure it, and I have 55 grams. To calculate how many moles I have, I just take 55 times the conversion factor. Now, the way I pick the conversion factor is I want the number or the unit on the bottom to match that known quantity that I have. So I know 55 grams. I was given 55 grams in the problem. So I want to use the conversion factor that has grams on the bottom. So my choices are 1 mole per 44 grams or 44 grams per mole. And notice on this one, I'm going to choose 1 mole over 44 grams. Now, if I do that math, that just simply ends up being 55 divided by 44, which is 1.25 moles. Because if I take 55 times 1, at the top of that, that's just 55, and I divide by 44. And my grams cancel out, so I'm left with 1.25 moles. Or suppose that I have 1.25 moles of carbon dioxide. That's what I'm given in the problem. And I have to calculate how many grams of carbon dioxide I have. So I look at the CO2 and I calculate the molar mass, which I know is 44. And this time, since I'm given 1.25 moles, I'm going to multiply that by 44 grams over 1 mole. I use that conversion factor because the mole is on the bottom. And that's the same as the unit that I was given. So now my moles cancel out, and I get 1.25 times 44, which is 55 grams.